Hello, this is Team South Korea, and this is our final presentation for the ME2110 Fall 2020 project. The team members are Luke Teverino, Yen Reddy, myself, Andrew Rowetter, and Jacob Brody. Quickly into the problem introduction, our team would first like to say, on behalf of Team South Korea, we'd like to thank the South Korean Olympic Committee for allowing us to present this proposal for an autonomous Olympic competition robot. We are very excited for this opportunity to offer a consistent and accurate robot, continue the legacy of the South Korean women's archery team, and to build a secondary legacy in basketball competitions for the nation. On the project competition, there are two main tasks, archery and basketball, shooting 2 archery shots into the left side of the arena, 2 basketballs into the right side, and there's a money ball on the basketball side which can be picked up and deposited into those cups for extra points. For the design process, first off with the HOQ, the most important customer requirements that we determined from our house of quality were that it accurately shoots the arrow and basketballs and that the launcher also does not harm the users. These customer requirements can be related to engineering requirements with the minimum force the launcher can utilize and also the range of rotation of the robot such that it can accurately shoot these arrows and that also it will shoot them far enough without harming anyone. For some specifications of these engineering requirements, really important ones were the reload time and the maximum run time of the robot, and these correlated with each other, such that if it took too long to reload for the archery or basketball shots, we could risk running over the maximum run time allotted to us in the competition. The main function of this robot is to score points for the South Korean Olympic team. You can do so in two different ways. One is scoring the arrows by launching or reloading, and the other is scoring the basketballs by also dropping those simultaneously after it retrieves and loads the money ball. Specifications of this robot include many of the disqualification rules from the design project overview, and those really important ones are that nothing of the launcher crosses the foul line, since that can result in a disqualification of archery points, and also the maximum budget, since that is very important if we are selling to the Olympic Committee, that it does not exceed a too high of a cost, and then the maximum runtime of the robot being 1 minute, such that it fits within the constraints of the competition.
I'll be talking about our selected design. Our selected design name is Wally. We have three main components: the dropper, the archery, and the movement system. This is a system that we use to move the whole robot. We have 2 gears attached to a motor, and it's just a front wheel drive. So it can only translate forwards and backwards. This is our archery launcher subsystem. As you can see, we don't really have a reload mechanism. We just have 2 launchers that will fire separately. This is our dropper system. We use this to load the basketballs into the cups. We also use it to pick up the money balls on the way to the basketballs. As you can see, the solenoid there allows the basketballs to roll down and into the cups.
Over our alternative designs. To introduce alternative designs, I will go through the morph chart to better help understand our decisions for the different functions of these alternate robots. The first major section of the morph chart to look over is how to launch the ammo, or also known as the arrows. In this, we had a rubber band slingshot, a mousetrap catapult, pneumatics, motor tension, and motor centrifugal force. In addition, the second most important section is how to retrieve the money ball. In this, we had a PVC pipe, a claw idea, a scoop, silly putty / adhesive on the end of a stick or a rod, or a suction cup. To go on, our first alternative design is called Eve. She has a similar design as Wally for retrieving and dumping the money balls, as she uses a PVC pipe that folds out and folds back in, but where she differs is she has a revolving pneumatic cannon. So while Wally also has a pneumatic cannon, this robot reloads through a revolving system that's seen commonly amongst guns and also known as revolvers. In addition, we decided that to stay away from this idea because it would require more moving pieces, and this led to worsened reliability. This is our second alternative design. It's called the Mothership, as it's a stationary robot and does not move back and forth from the starting zone. It has an extender arm and a claw to retrieve and grab the money ball, and a track system like many of the other groups used in their final projects to extend out the basketballs and drop them in. In addition, it also uses a slingshot to shoot the arrows. However, as we went through the design more, we felt the track would have to be way too long and would have too much stress to extend out the arm that far, which would lead to failures. So I'll go on to our evaluations. So this is our third level evaluation matrix. And as you can see, Wally won with a 0.92 relative total compared to a 0.76 the mothership got and a 0.74 that Eve got. The two categories to really look at in this is able to retrieve the money ball, where the mothership only scored a 1 and Eve only scored a 1, while Wally we decided would score a 3 as it was a more reliable system. And the second category is easily reloadable. This is where Eve really falls behind with that revolver system, and we decided that Wally would be the easiest to reload, and therefore we went with her.
Results. With Sprint 1, as everybody is aware, we did get first place because we were able to get the basketballs into the green cup 5 out of 6 times. It was very advantageous for us to do so. However, we trusted our machine with the basketball, so we were more focused on the arrows, and over time, as you guys are aware, the machines can warp, and one of the arms was a little too low. In Sprint 2, we did not end up getting the basketballs into the green zone in round 2 and 3. However, we did end up getting the money ball into the green cup, so that was advantageous. In the end of the day, we did end up getting last in Sprint 2. Calculating our raw score. Here is a video of a run from Sprint 2. And to conclude, we wanted to come full circle, reflect on the past, and give advice and or what we would do next time for the future. So looking on back, when, especially in our testing methods, we really needed to make sure that we had a strict list of tasks that we were doing. I myself definitely get off task frequently, so being able to have a list of things we needed to accomplish was useful. Testing frequently and efficiently. This was the biggest issue for us, was we didn't test as much going into Sprint 2. That ended up hurting us. Fabrication methods, obviously, you need to try a variety of ways to fabricate something. It's not always going to be your first instant. Blood stains. Yes, don't grab white pieces when you have open wounds on your hands, or you will get a big red mark on your dropper tube. Having a set number of trials to accomplish per week of fabrication. Like I said, a big issue with us was testing for Sprint 2, so we wanted to make sure that in the future we were going to test a lot, and we have up until this competition. Setting mini deadlines to reward yourself, having smaller accomplishments rather than having one big deadline in November was easier, and for us to do things, for example, the basketballs in the beginning, that was our first deadline, and we were able to do that really well. Morale is key to success as well, and testing frequently even when you think it's enough. And lastly, here are references.
Recording has